Day 577 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2141, maximum running time of N computers. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out the link in the description so you can get you some. Now let's see what the question says. You have N computers. You are given an integer N and a zero index integer array batteries where the ith battery can run a computer for battery of I minutes. You are interested in running all N computers simultaneously using the given batteries. Initially, you can start at most one battery into each computer. After that, and at any integer time amount or moment, you can remove a battery from a computer and insert another battery any number of times. The inserted battery can be a totally new battery or a battery from another computer. You may assume that the removing of and inserting process can take no time. Note that the batteries cannot be recharged. Return the maximum number of minutes you can run all of N computers simultaneously. All right, y'all. So that may seem simple at first, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. But basically, we're given batteries, we're given an array of batteries and a number of computers. We want to see what's the maximum number of minutes we can run the computers at the same time. Each one of these batteries represents the amount of time that the battery can run. So let's take a look at example one. In example one, we have our input N equals 2, batteries equals an array of integers 3, 3, 3. So this means each battery can run a total of 3 minutes, and we have two computers. The output is 4. Explanation says, initially we insert battery 0 into the first computer and battery 1 into the second computer. So what that means is, so we have these two batteries right here. This is battery 0, this is battery 1. We're going to insert battery 0 into this computer and battery 1 into this computer. Because there's only two computers, then we'll leave this full battery to the side until we need it later. Boom. Then it says after 2 minutes, we remove battery 1 from the second computer and insert battery 2. So we're going to remove this battery from this computer, right? So this battery, this middle battery right here, as you can see, this middle battery and this middle battery is the same battery. First, this battery is connected to the second computer. Now we're going to remove this battery from the second computer and we're going to insert this full battery right here, right? This full battery we're inserting into the second computer. So now this first computer used up 2 minutes, and then this battery, this second computer right here is using a full battery. Boom. Then it says, note that battery run can still run for 1 minute. So note that this battery right here, this is battery 1, it still has 1 full minute left because we removed it after 2 minutes. But as you can see, it initially has a full battery that lasts 3 minutes. So we still have an extra minute in this battery. Boom. Then it says at the end of the third minute, battery 0 is drained. So boom, battery 0 was full. It ran for 3 minutes. Now it's drained, right? So, and you need to remove it from the first computer and insert battery 1 instead. So we remove battery 1 from this computer. Boom, this battery is now 0. This battery right here is now 0. We're looking right here. Boom. So we insert this middle battery that still has 1 extra minute left. We are inserting into this computer, this first computer right here. This second computer is still running and still has 2 minutes left because we had inserted a full battery into the second computer right here. So the second computer still has 2 minutes left. This middle battery or this first computer still has 1 minute left. Boom. Then it says where we leave off, and you need to remove it from the first computer and insert battery 1 instead. Okay, we did that. Then it says by the end of the 4th minute, battery 1 is also drained and the first computer is no longer running. So now these two batteries are drained. This computer is no longer running. It says we can run the two computers simultaneously for at most 4 minutes, so we return 4. So we're counting the minutes that we can have all of these computers, or really it's just these two computers running at the same time. Once one computer fails, then or runs out of battery, then they're no longer running simultaneously. So the question or the problem ends, because we want to know how long we can keep the computers running simultaneously, meaning they're both still running. And in this case, the output was 4 because we were able to do that in 4 minutes, right? So once again, we started with these two. Boom. After 2 minutes passed. That's when we switched this. Boom. Then 1 minute passed. This was done, and we switched it here. Boom. Then 1 more minute passed, and now both of these are drained. So in total, that took a total of 4 minutes, and that's why the output is 4. So just in case that didn't make sense to y'all, though, let's take a look at example 2. So in example 2, same principles. We have input n equals 2. Sorry, y'all. Input n equals 2. Batteries equals an array of integers 1, 1, 1, and 1. The output is 2. So in this case, we have two computers. Every battery only runs for 1 minute each. So then it says, initially we insert battery 0 into the first computer and battery 2 into the second computer, right? So boom, we put battery 0 here, battery 2 here. But remember, they only are going to last for 1 minute, right? So boom, this is battery 0 is on this computer. Once again, battery 2 is on this computer. We still have battery 1 and battery 3. These two, this battery right here and this battery here, they still haven't been used yet. They're still fully charged. Boom. It says after 1 minute, battery 0 and battery 2 are drained, so you need to remove them and insert battery 1 into the first computer and battery 3 into the second computer. So after 1 minute, that's all we get with these batteries, right? Only 1 minute each. After 1 minute, this battery is done. This battery is done right here, and this battery is done right here. But it's okay because we still have this battery and this battery, right? So we still have this battery and this battery. After the first minute, this battery is done and this battery is done. So we insert this battery and this battery. That's going to give us 1 more minute each for each computer. So this computer will get 1 more minute and this one computer will get 1 more minute. So after that, it says after another minute, battery 1 and battery 3 are also drained, so the first and second computers are no longer running. We can run the two computers simultaneously for at most 2 minutes, so we return 2. So as you can see, the first minute we're running battery 0 on this computer, battery 2 on this computer. Boom, then they're both drained after 1 minute. Boom. So but we still can get another minute because we still have this full battery fully charged and this battery is fully charged, right? This one and this one. So now we just connect this one to the first computer and this one to the second computer, and that'll get us an additional minute. So in total, both computers were running at the same time for 2 minutes. Boom. So these two for one computer and these 2 minutes for the second computer. But really it'd be it'd really be this battery and this battery for this battery and this battery for the first two computers or the first 2 minutes, and then this battery and this battery for the second minute. Or for the first minute, and these two for the second minute. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. Now, the first thing we're going to do is we're going to sort the batteries descending so we can process the largest ones first. So we're going to say let B equal batteries dot sorted, open up the parentheses by colon and put the greater than sign just like that. Boom. Then we need the total sum of all battery capacities. So for that, we're going to declare a variable called T, set that equal to batteries dot reduce, open up the parentheses 0, comma plus, and then we also need an index to track how many large batteries we can exclude. So we'll come outside of this and we'll say comma I, which is just, we're still declaring I as another variable. That's what this comma means. So they're both, it's just the same way of writing two variables, right? So this I, we're going to say I equal to 0 to start. Boom. Now, while the current battery is too large to fit into equal distribution of total time, we're going to exclude that battery from the pool. The largest battery has more capacity than the average allowed runtime if we spread total energy, or T, across the remaining n-1 devices. So that means this battery is too large to be part of the equal distribution, so we remove it and recompute. So for that, we're going to say while B square bracket I is greater than T divided by, open up the parentheses, n minus I, come outside of that, we're going to open up the brackets and we're going to remove its energy from the pool by saying T minus equals B square bracket I, come underneath that, and we're going to increase the excluded battery count by saying I plus equals 1. Then, after removing all the oversized batteries, the remaining energy T can be evenly distributed across the remaining n minus I devices. So we could just come right here and we could say return T divided by, open up the parentheses, n minus I. Boom, y'all, that's all she wrote. Let's give it a run. Make sure it runs properly. Before we submit it, it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 23 milliseconds beats this dash. I don't know what this dash means, but I'll take it, y'all. And with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.